I'm Randy Reed, the Executive Director of the National Lighting Bureau, and today's session is entitled Safety First, Making Driving Less Lethal. This is part of our Let's Talk About Light and Health series, which is a collaboration between Mount Sinai's Light and Health Research Center and the National Lighting Bureau. Today, we are joined by John Bulla from Mount Sinai's Light and Health Research Center, and the session is sponsored by Current. John, welcome.
Thanks, Randy. Glad to be here.
Well, we're glad you're here as well. Now, tell our audience just a little bit about your background and how you got started in automotive lighting.
Yeah, sure. Well, back in the late 80s, early 90s, I was a student at Rensselaer Polytechnic Institute, RPI, and I was in computer science, actually, and then took a job working for the phone company in a cubicle in New Jersey. I was basically Dilbert for a while. It wasn't the most stimulating job. I was writing code that would route phone calls. And so at one point I decided to give a professor at RPI a call who I had taken a writing class with. And he convinced me to come back to RPI to study what was called communication and rhetoric, basically technical writing. So I thought that would be worth a try. And so I came back, and in the summer of '91, I needed a job to get me through until my classes were starting in the fall. So I looked on campus and found this place called the Lighting Research Center. And the director, Mark Ray, there was looking for some help with some writing projects that he was doing. So the timing was perfect. Yeah.
What year was that? What year was that?
This was the summer of 1991. One of the first projects that I got involved with as I was kind of shifting from a writer and editor to a researcher was this project for New York State Department of Transportation on snowplow lighting. So these the lights that are on snowplows. So it was my first transportation lighting experience, and it was what got me started in this area of transportation lighting and human factors.
Well, that kind of leads me to my first question. When we talk about roadway lighting and safety, what does that encompass?
Well, when we think about what helps us see and get around safely at night, when we're either driving or walking, you have the road and sidewalks and parking lots and other kinds of areas. We often think of, the fixed roadway lighting, the street lights that are mounted on poles, and those are definitely, part of that system. But there's also, traffic signals at intersections, signal lights that are on cars, headlights on cars, flashing lights on emergency vehicles, signs, and even markings on the pavement. All these things are kind of giving the visual environment, and they all need to work together, even if they don't always, they're not always planned that way. They all work together for better or for worse, whether we like it or not.
So there are more accidents per roadway mile at night than during the day. What makes roadway lighting and automobile lighting so difficult?
Well, a lot of, the difference is really has to do with just the fact that it is, at night, it's much darker. The light levels are much, much lower. And so we usually don't worry a whole lot about what we call visual performance in interior lighting. So visual performance, you could think of as the speed and accuracy of, how well we can see things, detect them and identify them. But at night, because it's so much darker, it's orders of magnitude darker, it really does matter, visual performance. And so things like the light levels do make a difference, whereas they don't in an office or a store or a classroom so much. And part of the problem is also that we don't really we do a lot of things that don't really help ourselves when we're outside at night, either walking or driving. Many of us will, wear dark clothing at night. And so that doesn't help with contrast, right? Our eyes are always looking for that contrast. And so dark clothing against dark pavement doesn't give you a whole lot of contrast. We also do things like just have a lot of illuminated signage all over our roads, especially in more urban areas. Even on our vehicles, we've done a study that showed that more than 2/3 of all vehicles have at least one headlight that's badly misaimed. And what that does is if it's misaimed too low, it really reduces our ability to see what's ahead on the road. If it's aimed too high, then you end up creating a lot of glare for other drivers. We're doing things like putting more and brighter flashing LEDs on our police cars and fire trucks, and that can be pretty chaotic as well sometimes. And just thinking about the geometry of these different lighting systems. Streetlights are very good at putting horizontal illuminance on the pavement, lighting up that horizontal surface of the ground, whereas headlights are shooting across and putting light on vertical surfaces. So you have these two systems that sometimes end up actually working against each other to create contrast. And then finally, we spend a lot of time either driving or walking, looking at these glowing rectangles, our phones basically, and they can be distracting, but they also put more light in our eyes that isn't what we need to see when we're outside at night. So they actually can create disability glare, making it harder to see other things, tripping hazards, people walking along the sidewalk, and those kinds of things. So we do a lot of things that we don't help ourselves often when we're outside at night. And this is all going on, in a place where you have, 1,000-pound vehicles going by right near where people might be walking. So it is a potentially hazardous situation for sure.
Well, what do crash statistics tell us about the potential for lighting to make things better?
Yeah, that's a great question. And we do know that lighting can make things better. We have looked at, for example, in the state of Minnesota, they keep good track of their roadways and intersections on state roads. And so we've looked at all of the state roadway intersections in the state of Minnesota, for example. Many of those have lighting, but many don't. So you can actually look at situations where you have lighting, where you don't have lighting. They have very clear lighting practices. And what we found is, again, as you might expect, the intersections that have lighting tend to have fewer crashes at night. That's what we would hope to see. But what's interesting is that we can actually use lighting software to say, well, here's what the state of Minnesota does on those state roadways and those intersections. And we can actually calculate using visual performance models, how much was visibility improved when lighting was at those intersections compared to when it wasn't there. And what's important to do is that you want to consider also that people are driving with their headlights on at night. And so that's part of the equation as well. It's not just the roadway lighting, but it's that combination of roadway and vehicle lighting.
Okay.
Well, yeah. And what we found is there really was a relationship between how much visibility improvement there was. Those situations tended to have greater reductions in crashes at night. So visibility does give us better safety.
Do roadway lighting people and automotive lighting people talk to each other?
That's another great question. And unfortunately, historically, that has not been the case. There's obviously overlap, right, in what people are trying to accomplish with safety. People who design roadway lighting systems are trying to improve safety. The people who design and develop vehicle lighting are doing the exact same job. But they really come from very different industries, from very different, even from very different regulation sectors, for example. So street lighting, roadway lighting is often done at a public level, right? So a city or a town or even a state will decide which locations are going to have roadway lighting, where are we going to put this, whether it's a residential neighborhood or an intersection, a dangerous curve, all these kinds of locations. But vehicle lighting is very different. It's part of essentially a commercial product, a consumer product, right? So that lighting system is part of a vehicle that someone's going to buy based on a whole lot of decisions that have nothing to do with safety, right? Styling, prestige, the name brand, reliability, and that lighting system goes with the car. And so, it really is very different audiences that these systems have to, speak to. What's kind of interesting is that, most roads are not lighted. More than 80% of our roads do not have any kind of outdoor fixed pole mounted lighting. So really headlights are often the majority of the lighting that's out there. And many of our standards for roadway lighting historically have not considered that vehicle lighting would be part of the picture. That's beginning to change. Some of the recent versions of the recommended practice for roadway lighting from the IES, for example, do consider certain times when headlights can do just as much good in terms of helping people see than the street lights. And maybe that gives us a chance to not use as much street lighting, for example, as we might otherwise want to, and reduce things like light pollution and those kinds of issues.
The problem with that is, to your point, all the vehicles are different. So
Yes.
some vehicles can provide that new enhanced light and others cannot. So I guess you've got to plan for the lowest common denominator.
Right. And another place where that comes into play is the fact that, you know, our vehicles typically will have two types of forward lighting. So you have low beam headlights and high beam headlights. One, I guess, bad habit that we as drivers have gotten into is really almost always using our low beam headlights as the default. Maybe it's because we don't want to create glare to other drivers. Really, we don't know. Maybe it's just inertia, right? You don't change it if it's your headlights are on. We don't often think to use our high beams, and there have been studies that showed that 75% of the time, even on rural roads with no other traffic, people are still driving, you know, at pretty high speeds with their low beams on, and that's clearly a suboptimal situation.
But there are these adaptive lights now that will automatically put high beams on when cars are not coming, correct?
That's right. And those systems have gotten a lot better. I think in the 1950s, some car companies had some sensors on the front of their cars that were supposed to do this. They never really worked very well, and they didn't really stick around. But now that we have, you know, cameras and other kinds of detectors that are very good, those systems can actually do a very good job at detecting oncoming headlights or preceding taillights, so that you know you're not going to shine those lights into other drivers' eyes. And what's interesting as well is that for many years, for about a decade, there have been these adaptive driving beam or ADB headlights that have been legal in most of the world, excluding the United States. What that system actually allows you to dim your headlights, because with the advent of solid state lighting technology, you have so many possibilities in terms of creating an array of light sources that are each lighting the road, a different piece of the road, if you will. And those systems can actually dim just the amount of light in the direction of oncoming drivers. And so you end up with the ability to have your high beams on most of the road, but you're only shining essentially low beam types of light levels into the eyes of oncoming drivers. So they see what looks like oncoming low beams, but you can drive with the benefit of your high beams everywhere else on the road, and it will actually follow them as you pass by. These lights will sort of dim on and off and sort of track the oncoming car. And they work pretty well.
They're not legal in the US?
Well, they just became legal in February of this past year. Interestingly, most of the world uses United Nations regulations or standards for vehicle lighting. And those standards are written a little bit differently than in the US. In the US, we've kind of been locked into this idea that there's low beam headlights and there's high beam headlights, and there's really not anything in between, right? So changing part of the beam to a low beam while you still have the rest of the high beam on is just sort of, it doesn't really fit in with the way headlights have been regulated in the US. Finally, they worked out a way that they could define what this adaptive driving beam system would do and a set of tests that you could measure. Part of the issue was in the United Nations regulations, the way to verify that the system works is an expert would drive with the vehicle along different kinds of roadway situations. You would drive on a hill, along a curve, in heavy traffic, in rural areas, and the person would literally just observe, yes, the system worked the way it was supposed to. In the US, that was seen as a little bit too subjective. Maybe it's a more litigious society we live in here in the US, and so it wasn't considered a good enough way to define that performance. So the Department of Transportation essentially came up with a series of tests and measurements that will define what an ADB or adaptive driving beam headlight system should do and shouldn't do. So now we have these rules in place. It's probably going to be a while before car makers are able to figure out all those tests and measurements and actually get some systems on the road. It's a pretty complex regulation, about 100 pages long. So technically it's legal in the US, but it's probably going to be a year or more before we start to see some of these on the road in the United States.
Do you see a day when the vehicles are communicating with each other through light, through Li-Fi, with autonomous vehicles?
That's definitely going to be happening. And some of it is beginning to happen. So there are ways that, these vehicles can modulate the light levels at much higher frequencies than we would ever be able to see as humans, but which can easily be detected by sensors. So you can have systems that can, track the locations of other vehicles, how far away they are, how fast they may be moving, whether they have just started to slow down. So all this type of information can definitely be part of that system. And it's going to be something that's going to only increase as we start to eventually see driverless vehicles, beyond just the beta testing that has been going on over the last few years. That's going to be a big part of that new infrastructure within the vehicles.
Okay, let's move on a little bit and talk about emergency vehicles and lighting for emergency vehicles and perhaps distractions that can cause.
Yeah, and that's an area that we're working in right now at the Light and Health Research Center. We were doing some research with the National Institute of Occupational Safety and Health, or NIOSH, and also the U.S. Fire Administration through the Emergency Responder Safety Institute. So yeah, we've all driven at night, and when you see those flashing lights somewhere in your peripheral vision, I mean, what's your first instinct?
Well, my first instinct is I'm getting ready to get pulled over.
Yeah, you look at the speedometer and see how fast you're going.
I think
Something's going on.
Yeah, but then if I see like a fire truck or emergency, okay, then I figure, well, someone is injured. But what happens at night to me, they're so bright. I just want to cover my eyes. Now I'm slowing down, I'm pulling over. I just want to cover my eyes because they're just too bright, in my opinion.
Yeah, and I think you're onto something, Randy, because what we found is that, just like you said, those flashing lights they use flashing for that reason, that it is something it's very easy to pick up, especially in our peripheral vision. We're very sensitive to changes. And so flashing is an ideal way to get your attention. And so the idea is, well, if one or two lights is good to get my attention, then 5 or 6 that are even brighter must be even better, right? And so, LEDs have really, in many ways, happily stepped in to help us out with getting people's attention. They're very efficient, so they get very bright. They're very easy to flash on and off, and they come in these very saturated colors like red, blue, and yellow, and so on. So they're very distinctive. But this is probably an area where some of that technological development has actually gotten a little ahead of the standards. So remember, it wasn't that long ago that a lot of these emergency lights were a halogen source behind a colored filter that might be rotating. And so, a lot of the requirements in terms of making sure those lights are bright enough so that, if you are on a sunny day, for example, you want those lights to get your attention. And so a lot of the standards really have just focused on the minimum intensities that are needed to make sure that under those worst case conditions, essentially a bright sunny day, that those lights will be bright enough to get our attention. And so, really no one was ever worrying about the halogen lights being too bright, because you just had a limitation. They would drain the battery of the vehicle because they had to use such a high wattage. But LEDs have really, those advantages of LEDs in terms of power and brightness have actually created a situation where, people are using more and more of these lights because they don't drain the battery. And also because those standards are minimum levels, you can go higher than the standard and you're still meeting the standard. And so many people often look at these in terms of saying, well, I need to get people's attention in those worst case situations, a bright sunny day. But what happens is we don't often look at these lights when they're operating at night. And then when you start to have multiple lights and multiple vehicles, say there's an accident or downed power lines on the road and a lot of vehicles have shown up, you can get to really visually chaotic situations.
Sure. Well, what is AIM?
Yeah, so that's exactly what we've been looking at is really there are different aims of what these flashing lights are supposed to do for us. And the first one, if you look at AIM as the acronym, A is alerting, right? So that seems to be what we've kind of got that down pat, and then some. But there is another thing. If you look at the letter I, that actually means informing a driver about what a particular situation might be when there's flashing lights present, right? Is that a vehicle that's perhaps a snowplow moving along the road at slower than regular traffic speeds, or is it an accident where the vehicle is stopped and there might be other people and other cars around that location? Is it a work zone where you might have a lane closure, right? All that information doesn't necessarily get conveyed by some flashing lights. You know, we have learned some things that color, for example, we have generally each state has a different color coding. Red and blue lights are usually emergency vehicles like police and fire trucks and so on. Yellow is usually maintenance and utility trucks and those kinds of things. But that still leaves us looking towards a lot of bright flashing lights that are all going on and off at different patterns and not necessarily giving us a whole lot of information. So we've been studying glare a lot, and our work on glare from these lights has told us that, you know, intensities at night of these lights need to be much, much lower, even lower than the minimum standards that we're currently using for daytime vision. And many of these systems actually have dimming capabilities, but they're not used very often. Again, we have this idea that the brighter it is, the better it is. It's gonna be seen, which is true, but then it doesn't actually help us decipher what's there. So we've looked at things like the flash pattern, that having those lights rather than flash completely on or completely off, if they stay on for some small percentage of the light level, even when they're in the off mode. So rather than on-off flashing, you have high and low flashing. That actually helps us judge whether that vehicle is moving or whether it's stationary, whether we're getting close to it quickly. This whole idea of what we call closure detection. It's much better and happens much more efficiently and effectively if those lights never actually go completely on and off.
Okay.
So you can do things like that. There also are things you can do with the flash rate itself, right? LEDs are very good at flashing. We can create any kind of flash pattern or speed that we want. And we've looked at some studies where we actually found if you use a slow flashing rate, perhaps when a vehicle is stationary, and a faster flashing rate when that vehicle is beginning to move, people will very quickly learn, even if you don't tell them, that is a visual cue that tells them there's some information. We tend to interpret faster flashing as a more urgent or maybe more dangerous type of situation. And so we may as well put that knowledge or that intuition to work by actually changing the flash speed, for example, when a vehicle is about to leave an accident scene and go off, those lights could begin to flash more quickly when the vehicle is about to move, which we would intuitively help us to understand that, you know, we want to be more careful when we're approaching that location.
But we don't do that now, is what you're saying.
We generally don't. No, the whole idea tends to be get that information, you know, get their attention, and we kind of stop there. We don't really often go out of our way to inform drivers, or the letter M is manage, right? So you want to sort of influence what a driver is going to do. You can do things like sequential lighting. If you have a lane closure, you might want to tell people, hey, I've got to move over one lane to the right or to the left. And using sequential lights, we found that drivers will, again, intuitively understand if the lights are flashing in sequence from right to left, that they need to move over to the left. We found they do that more quickly and more smoothly when the lights are sequential than when they're just flashing randomly. So you can do things to manage driver behavior as well. But again, it's sort of understanding that these lights have more than one function. It's not just about getting our attention or alerting us, that we have to do some informing and managing as well.
Well, tell our audience a little bit about some of the projects that the Light and Health Research Center is working on now regarding roadway lighting.
Yeah, absolutely. So right now at the Light and Health Research Center, we're working on a study for NIOSH, the Institute for Occupational Safety and Health, to help people understand what the colors of the flashing lights, as well as the colors of the vehicles themselves and their markings, right? These vehicles are often painted with special colors, and they have reflective markings on them to identify them as a maintenance vehicle or an emergency truck, an ambulance or a police car, for example. So we're actually looking at how we can coordinate the lights on the vehicles as well as the color of the vehicle to make sure that people can make sense of that scene and pass by safely. We want them to know, is this a construction work zone? Is this an emergency situation, which might have been an accident? Is this a downed power line where you might have the road or part of the road closed because of a tree or a power line in the road? So we're actually starting with some laboratory studies with little scale model vehicles that we've set up with different colored vehicles and different colored lights to help understand, how do people perceive these? How do they judge what type of situation it is and how they should respond? Then we'll follow up in the next year in a test track with full scale vehicles with different colors. And we're also looking at sort of the brightness of those reflective markings as well as one of the issues. We've talked about how some of those flashing lights can be too bright. Sometimes the reflective markings on those vehicles can also be very bright. The sheeting on those materials are very efficient at what we call retro reflection. The idea is it shines the lights from your headlights back towards your direction. Sometimes those materials that are on those trucks, again, the idea is if type 1 materials are good, then type 5 must be even better and type 10 is excellent. Well, that may be true just to make sure it's bright, but sometimes these things can actually be too bright. And so we're looking into a study with the Emergency Responder Safety Institute to find out when those marking materials might actually be too bright on emergency vehicles.
What would you change to improve safety at night?
Yeah, I think what we've been learning, and really I think the big lesson is that you can often do more with less, especially with less light. So we talked about the crosswalks where you can actually use 75% less illumination and get the same or better visibility of the pedestrians. You can do that with other types of systems as well. And one of the concerns that we've been looking at is, at night in things like parking lots, people often feel a little anxious if they have to, say, walk across a parking lot at night to get to their vehicle. And so one of the things we've been looking at is really what type of lighting helps people feel safe and secure as they're walking at night. One of the factors that makes a big difference is the uniformity of the illumination. So if you have, bright spots of light and then dark areas in between, that tends to make people feel less safe because there's places where people could potentially, be hiding. And that if you can't quite see them, if you can't see the path to your vehicle, you're not going to feel as safe. We found that you can actually, again, reduce the light levels by more than half if you can use more uniform illumination in areas like parking lots. And that obviously has benefits for energy use, for light pollution, but you'll actually make people feel safer as they're walking in these areas, whether it's a downtown sidewalk, parking lot, anywhere where you have pedestrians and you want those pedestrians to feel safe and secure.
Well, John, I want to thank you for joining us today. I want to again thank our sponsor, Current, and we will now open the floor to questions.
Great. Thank you, Randy.